everyone. Oh my goodness. Look what I found. Look what I saw. I saw this moving truck the other day, and it had, I know it's hard to believe, it's like almost impossible to believe, but it had this on it. And so we figured, well, it must be a sign. We should probably start Unit 3, which is logs and exponents. How exciting. So as we're starting this unit, we're going to start with some review of what you all learned last year, right, with the properties. And it's okay, you might not remember it all right now. That's the purpose of this video, is to remind you of this information. And this is like, I don't know, guys, this is like the real test. Like, how engaged were you fourth quarter, the end of third quarter? This is actually one of the first things that we learned right at the end of third quarter when we left back in March. So logarithmic functions and their properties. So you might need to go back and pull out some stuff that you have from AAF to look at and use this as practice. But this is very important to make sure that we remember it, because this is something you are going to be expected to be able to use. So using the basic properties of logs to evaluate, expand, and condense logs. So let's see what we remember. So logarithmic functions, remember logarithmic and exponential form. X has to be greater than 0, and B, your base, has to be between 0 and 1, has to be greater than 0, but it cannot be 1. Right? So it's got to be greater than 0, but it cannot be equal to 1. Or maybe you remember what happens or what we talked about when it is equal to 1. So this is what the form looks like. Y equals log base B of X if and only if, that means by it's a definition, it works both ways, B to the power of Y equals X. And so maybe you recall switching between, we started with exponential, but switching between exponential and logarithmic and being able to move between the two and using one to solve the other. So this is your base, or this is your base, and it has to be greater than 0, but it cannot be equal to 1. And right, if you think about that, the reason would be, if this is 1, it doesn't matter what this exponent is, your output is going to be 1. Right? So it's not going to be an exponential function, or it's not going to be a logarithmic function, because that would mean that anytime I plug, all of my X values are going to give me an output of Y. Of 1. Right? So I'm going to have just a line. It's not going to be an exponential function. And if this were negative, it's going to oscillate. It's going to go back and forth. It's not going to be an exponential function, or it's not going to be a logarithmic function. So it's got to be greater than 0, but it cannot equal to 1. Okay. And X is your argument. It's your output. It's going to be greater than 0 as well. So if we want to start here, rewrite 32 equals m to the power of 2.4k in logarithmic form. Log base m of 32 equals 2.4k. Right? And then if I needed to isolate k, I could divide by 2.4. Right? That might be something that I'm doing there. So this is saying, what power turns m into 32? The power that turns m into 32 is 2.4k, right? The power that turns m into 32 is 2.4k. So some basic properties of logs. Your base has to be greater than 0, but it cannot be equal to 1, and any real number y. Log base b of 1 equals 0, because b to the power of 0 equals 1, right? B to the power of 0 equals 1. This is your exponent, what it's equal to. Log base b of b equals 1, because b to the power of 1 equals b, right? Again, b to the power of 1 equals b. Logs are exponents. Log base b of b to the power of y equals y, because b to the power of y equals b to the power of y. Right? They end up just canceling each other out. B to the power of y equals b to the power of y. Right? So if I'm saying what power turns b into b to the y, well, your answer's got to be y. And finally, b to the power of log base b of y just equals y, right? Like they're inverse operations. Logs are exponents. I could rewrite this, and you can see it, log base b of y, right? Change this to a log. Log, this is just your exponent, right? That's what it equals. Just like all of these are just your power. They're just your exponent. Log base b of y equals log base b of y. So it ends up canceling out. So that just equals to y. Common logs and natural logs. So hopefully you recall a little bit about this, but for short, we use the conventions log base 10 of x, which is known as the common log, is just log x. So that's what you probably see on your calculator, right? This is the common log. This log base e of x, we see ln of x, right? And this is called the natural log. That's not how you spell log. So if we want to evaluate and simplify all of these based on the information we just talked about, let's go for it, right? So we're simplifying or we're evaluating. I'm not solving anything. So log of 100, that's like saying log base 10 of 100, right? So what power turns 10 into 100? Oh, this is just 2, right? That's just the number 2. This is equivalent to 2. What about this one? Log base 81 of 9. So what power turns 81 into 9? Well, it's getting smaller, so it has to be between 0 and 1. And oh, I'm taking the square root, which is the same thing as raising something to the 1/2 power, right? I can think about this as 81 to the 1/2 power equals 9. Oh, we just talked about this, right? I could rewrite this and say log base 6 of something has to equal to that exponent, log base 6 of 2.37. Oh, look, that something is just 2.37, right? Or I'm doing something then undoing it. They're inverse operations. So this is just my answer. Ooh, look at this one. Let's see, ln of the square root of e to the 5th, right? So this is like log base e of e to the power of, well, how could I rewrite that? 5/2, right? Right? Raising it something to the 1/2 power and square root are the same thing. So that is really e to the power of 5 and then 1/2, and right, a power to a power, I multiply. E to the 5/2 is really what that is. So what happens here? Well, what power of e, what power turns e into e to the 5/2? Well, 5/2, right? It's e to some power has to equal e to the 5/2. Ignore. They have the same base. Ooh, this is a fun one. Log base 1/27 equals 3. So what power is going to turn 1/27 to something has to turn into 3? Well, if you remember, for something to become a fraction, to go into like the denominator, to switch which part of the fraction it's at, it's raising it to a negative power, right? So I'm going to have to raise this to a negative power. And it's getting smaller, right? This is just 3 is the cube root of 27. So it's going to be -3. Right? You can use your properties of exponents there and think, well, if 1/27 is 27 to the -1 to something has to equal to 3. Okay, we can get this to have a base of 3. 3 to the -3 to the 3rd times -1. Oh my gosh, it's -1/3. Oh my goodness, I'm sorry. To something has to equal to 3. Right, so now I have a base of this. And I get -3 times x times something has to equal 3. And then you can set their exponents equal to each other. So I get -3x equals 1 divide by -3, and I get x equals -1/3. I'm so sorry, guys. Butchered that. All right, moving on. For f over here, what power turns 10 into 1 over 1,000? It's got to be negative. So negative, there's 3 there, -3. That is the common base there. You don't see the base. Ooh, what about this? This is saying 5 to some power is going to equal to 125 to the power of n. Okay, let's see. Well, I'm going to think about this. This is going to be to the 3rd power, right? For it to be 125, so it's got to be 3n. Right? I can rewrite this as 5 to the 3rd, and then there's an n there. So what am I going to have to raise it to? 3n. And you can try that out, right? 5 to the power of 3n is, oh look, 125n to the power of n. And last but not least, this nice one right here. So you've got e to the power of 4 times ln of 4. Okay, so this is log base e, right? What can you do with this 4 here? Maybe you can bring that up as an exponent. Do you remember that property? So this is the same thing as ln 4 to the power of 4. And then those are really going to just cancel. And I'm going to end up with 4 to the power of 4, which is what, 64? I believe it is. So I end up with 64 there. So if you did e to the power, and you can check me on that, e to the power of 4 ln of 4, I get, oh my goodness, this is 256, isn't it? 4 to the power of 3 is 64. I'm on a roll. You guys are seeing me at my finest. So that's that property where you can write it out front, right? So 2 log 7 is the same thing as log 49. So you're bringing it up. Ooh, that like cut out of the screen. Right, so that is one of the ones that we're going to talk about right here. So a few other properties is the product rule, the quotient rule, and the power rule, which I just briefly spoke about. So just remember that b is still not equal to 1, and c is any real number. Be any real number. Wow, sorry. So the product rule is when you're multiplying the arguments, you have added and they have the same base, right? If they don't have the same base, this doesn't apply. So I'm adding 2 logs that have the same base. Oh, I can multiply their arguments, right? Think about your exponent rules and it's opposite, right? If you're multiplying and they have the same base, you're adding the exponents. Now, if you're adding, they have the same base, you're multiplying because think inverse operations, like they're inverses. Logs and exponents, they relate. If you're subtracting and they have the same base, you're dividing their argument. So we can put it together, we can pull stuff apart. The product rule says log base b of an argument to a power, I can pull that power out front and I'm really multiplying it. It's like it's the multiplier in front. Right, so I can rewrite that, and that is called the power rule. We also talked last year about the change of base, right? So this is useful and helpful to us for a variety of reasons, but sometimes I might want to change it so that it is the common base, right? So then I can actually solve it because it's not something that I know how to work with. So for instance, if I had log base 7 of 12, right? So that's this. Well, I'm going to change it. I can change it to whatever base I want, but maybe I want to change it to have a base of 10. I could say log of the argument over log of the base. You might also see it where it's going the other way. and you're trying to divide, and be careful that you're not mixing up your properties of this, right? I'm not dividing the arguments, I'm dividing the actual logs. That you could get a problem that says log of, you know what, log base 7 of 8 divided by log base 7 of 2. And you're like, oh, what do I do with that? Well, I could use my change of base formula backwards. And this is log of the argument over log of the base. And oh my goodness, what is that? That's just 3. Right? So this statement would have just been 3, but you're like reversing the change of base formula. And I could be changing it to anything, right? Like maybe ln, maybe, I don't know, maybe it's so that you can use some of these other properties to combine things. So we're going to stop there. You guys have some practice with this in the homework assignment, and I would suggest you try that, and then we're going to come back together and work on using some of these to solve some some logarithmic equations using and practicing some of this information. So I will see you guys there.